So let us try to understand what are gases or what are the properties of gases. So the state of matter in which the particles are arranged far apart from each other, the force of attraction between the particles is very weak, that is, the intermolecular forces of attraction are very weak. The intermolecular spaces or the spaces between the particles is very large. They have large spaces between them. The movement of particles, that is, the particles are free to move in any direction. So, from this, we come to know that the molecular arrangement of gases could be of this form. That is, the molecules are far apart from each other, they have lots and lots of spaces between them, and they are free to move in any direction. So, the molecular arrangement in gases could be shown in the form of these balls. So, just the kind of movement that these balls are having placed here in the tray is exactly how the particles in gases move. So they can move in any direction, up and down, sideways. So they are free to move in any direction. This is exactly the kind of the kind of movement that the particles in gases have. Or the movement of particles could also be compared with the kind of movement that these channels have placed in this box. They have lots and lots of spaces between them. They are free to move in any direction, sideways, up and down, in any ways. So they basically have lots and lots of spaces between them. This is exactly how the molecules in gases are arranged. So I can give you another example for the kind of movement that the particles in gases have. If you ever happen to go to FRI or maybe any park, and there are maybe very few people, just around say 3 or 4 people in the park, so what is the first thing that you people will do? You will definitely enter the park and start running. So because there are very few people in the park, so you will definitely have lots and lots of space to move. So you can idly run in any direction. That is exactly, so you can just imagine yourselves to be the particles present in gases, and you have lots and lots of space to move. That is exactly the kind of movement that the particles in gases can have. Since they have large spaces, so they have lots and lots of space to move. So therefore, they can exert pressure in all directions. They can move idly in any direction. So from this we conclude that the gas particles, they do not have a fixed, that is, do not have a definite shape nor a definite volume or a fixed volume. They are free to move in any direction and occupy the entire space available to them, and thus they are called fluids. Fluids mean something which can flow. And the gases are highly compressible. By compressible, it means that you can actually fill in gases in any small container. You must have observed that whenever you get gas cylinders at home, they're the red colored cylinders. So, LPG gas, liquefied petroleum gas, is filled in them. So, this is the best example of gases being compressible. You have actually got those gases compressed in red cylinders. So, that is an example of a cooking gas being compressed, which is known as LPG. Let us do a few more examples here now. So, oxygen is another example of a gas. It is a gas which we inhale. Inhale means we take in. Carbon dioxide is another gas, but it is a gas which we exhale, that is, give out. Hydrogen is another gas which is ideally the most abundant gas in the entire universe. Nitrogen is another gas which is most abundant gas in the Earth's atmosphere. LPG, we have just discussed, is known as the cooking gas. CNG, compressed natural gas, which is now used as a fuel in vehicles. So these are a list of few gases which you are very well aware of, and these gases can easily be compressed. That means they can easily be stored in cylinders. Apart from this, let me give you one very interesting example. You all must have at any point in time had these cold drinks like Coke or Mirinda or Limca. You must have observed that the moment you open the lid, you get that fizz sound, right? So that fizz sound is because of the gas carbon dioxide which has been compressed in those bottles, and that is how we hear that sound. So this is another example of gas carbon dioxide being compressed in those bottles. So, children, I hope you all have understood today's topic. Stay home, stay safe. Take care.